Now we have discussed how we can write expressions with indices, how we can apply a lot of different rules to indices, and in this session I want to discuss with you how we can actually use our knowledge to represent a variety of numbers in what is called the scientific notation. So that's the scientific notation, and you also can find other names for that. For example, the scientific form or the standard index form. Now this has the word index in it, which shows that we are using indices in this case. And very annoyingly, in the UK, this is also known as the standard form, in contrast to what is called the standard notation. But I will mention that later on. So what is it? Why can we use it? How does it work? Well, actually, it helps us to write very large and very small numbers quite accurately, without the need of having to worry about getting the numbers of places right or something like that. So what does it look like? So for example, let's have the number 328. And I put a decimal place here and say 0.0. It's an interesting thing here because I have put this decimal point here. Now, if you are from the continent, from Europe, you will probably a little bit confused about this decimal point because in places like Germany or wherever on the continent, this will be usually replaced with a comma. So in Germany you would write 328, comma 0, which is the same thing. But in the UK and most other places, this indicates the decimal point. It sometimes causes confusions among students and teachers, but I will stick to the decimal point here. So 328, now that's a very simple number, and we don't really have to worry about it, but we can say that this is 3.280 times 10 to the power of, well, times 100. Let's put it this way. 3.280 times 100, this is the same as 328. And while we are at it, it's quite interesting. If you are a German speaker, you will notice that. So in English, it's 328. Whereas if you say it in German, it would be 328. So in Germany, it is 308 and 20. That's how they say it in Germany, which is a little bit quite funny. Okay, so these are cultural differences. So 328, we can write this as 3.280 times 100. And we know that we can write 100, of course, as 10 times 10. Or, if we so wish, we can write this as 10 to the power of 2. And therefore, we can write our number 328 as 3.280 times 10 to the power of 2. And that here would be the scientific notation. Scientific notation. And scientific notation is expressing a number just as a unit. That's the unit, that's the one before the decimal point. So unit, decimal point, more numbers if required, times 10 to the power of the correct index, of course. So how do we usually find this? And of course we can do this with a number of with large numbers or with very small numbers. So I just write one number here, 1, 2, 3, 4, 5, 6.7. Let's say we do it like that. And we want to express that as a standard, as the scientific notation, I should say. I don't want to use the UK term. So we would write this as we want the unit. So the unit here is the first number that we are using here. So that would be 1. And then it would be point. That is our decimal point. And now we write the other numbers that we have. 2, 3, 4, 5, 6, 7 times 10 to the power of, and now we need to find out what this n is. And how can we find that out? Well, there is a simple trick that you can use. And what you do is, in order to find out what this n is, you count how often you have to move this decimal point here, this decimal point. How often do you have to move it to get it to this position here, just after the 1. So let's see how we do that. So we would move it 1, 2, 3, 4, 5. So we would move it 5 times. And therefore it would be 10 to the power of 5. So this number would be 123,456.7. And that is what this indicates. So that basically means 1.234567 times 100,000. That is this 10 to the power of 5. So here, in order to find for a large number, we move the decimal point to the left. So large number, the decimal point is moved to the left. And of course, you can imagine what we need to do. We would then write a small number. Let's say we have 0.0003456, and we can write this also as a scientific number. So we can write this as, we take the unit 3.456. So we want to have the decimal point in this position here. So now we need to calculate, when we write this as 10 to the power of n, we need to calculate how often do we have to move the decimal point to get it to this position here. And we can do that. So it goes 1, 2, 3, and we have arrived here at 4. So that would be 4. But we need to be careful, because we have a very small number. We would need to express that again as something index of base 10. So this would be, in this case, 1, 2, 3, 4, 10 to the power of negative 4. Why is it negative? Well, because we would say we have 3.456 divided by 10,000, and that would give us this number here. And we know that 10,000 we can write as 10 to the 4, so we have 3.456 over 10 to the power of 4. And this we know we can write as 3.456 times 10 to the power of -4, because remember the fraction line that is sort of reflected in this negative sign. Very often you will see this in calculators, that this scientific form is indicated, and it will not necessarily give you it in this fairly long form. What you very often will see on a calculator is that it gives you sort of the calculator speak of it, and that would be in this case 3.456, and then instead of times 10 to the -4, very often the calculator puts in an e, and that stands 10 to the exponent of. This e that you see in the calculator is 10 to the exponent -4. So that is what you might find on your computer display or a calculator display. And likewise, for this one up here, you would find 1.2345667 E5, or sometimes it is E plus 5 to indicate that we've got a positive number. And that's, again, that is exactly the same, but that is what your calculator might show you. And sometimes on calculators you also find this as a lowercase e, but that's not very common because that could be easily mistaken for another number, actually, which we will discuss in the logarithm section. So in the following there are a few practice questions that you can see how you can convert numbers into scientific format. But of course we can also convert from the scientific format into the standard, into the normal format. So if we've got 1.234 times 10 to the power of, let's say, 4, we can convert that. We can just simply say this is 1.234 times 10,000. And what we do here is we know that we have moved the decimal point 4 places. So what we do is 1.234, and we can cheekily add a few zeros. Although when we discuss about significant numbers, we will see that this is technically a sort of a little bit of a dirty trick. But what we do now is we have the 4 here and we move them now back. Remember, for large numbers where we get a positive number here, we move to the left, and if we want to convert it back, we want to move it to the right. So we move 4 places to the right. So 1, 2, 3, 4. And now our decimal point would be here. So this would be converted into 1, 2, 3, 4, 0. And our decimal point would be here. So that would be 12,340. And likewise, if we, for example, have, say, 0.00135 or something like that, or I should probably say we had, let me cancel that. Let me say we had 1.357 times 10 to the minus 3. Let's say we do it like that. So we can convert that. We know that we have a small number. So what we can do is we write a few zeros like that. 1, 3, 5, 7, and here was our decimal point in the first place. And now we need to move the decimal point, and we now move it in this direction, because before we had to move that, when we had this number, we moved it in this direction. Now we move it in this direction. So let's see, we need to move it 3 times. 1, 2, 3. So here we would have this number. So we would have 0.001357. And that is how we can convert large and small scientific numbers into notation, into scientific notation like this. Or really all we need to do is we need to move the decimal place or the decimal points to the right position, which is indicated by the index of the 10 to the power of. So I hope this makes sense, and I'm sure you have done that at school, but practice certainly will help you to master this concept so that it comes as second nature for you to write large or small numbers in this scientific notation. So thank you very much for watching, and I hope this made sense to you.